Hello, it's Scott Manley here, and today I want to talk about the new generation of high bandwidth satellite constellations that are being proposed and launched as we speak. This sounds a lot like the late 1990s, where we had Iridium, Orbcomm, Globalstar, Teledesic, all making similar plans. Now, Orbcomm did find success with providing companies ways to talk to their assets around the world. Iridium proposed a worldwide phone network where you could use a satellite phone anywhere in the world, and it failed terribly. They did go bankrupt, but that meant they could write down the capital cost of launching the satellite network in the first place, and they did become profitable enough that both Orbcomm and Iridium have since launched second generation version of their clusters on board SpaceX rockets. So while Iridium is supposed to work with a handheld device that's able to carry a phone conversation, the new generation of devices are able to communicate at megabit rates using flat pack phased array antennas. And, over these networks, they're talking about exabytes or even zettabytes of bandwidth over a month, serving 95% of the world's population. And the designs are all broadly similar. They use hundreds of satellites in low Earth orbit with phased array antennas that are able to handle multiple clients at different frequency ranges and different locations. They have interlinked satellites so that they can send data around the world quickly, and they will have base stations that provide gateways to the internet as a whole. So Starlink is the obvious high-profile option. It was set up in 2015 by SpaceX. They started a facility up in Seattle to develop the technology to be launched on SpaceX rockets. They launched two of them on board the PAZ payload last year. That actually launched out of Vandenberg, and I get a picture of that flying out of my rear window. But yeah, last week, of course, they really arrived, launching 60 satellites on a single Falcon 9. And ultimately, they're talking about 1,600 odd satellites in 550 kilometer orbits, and then expanding the network to 340 and 1,150 kilometer orbits with a total of 12,000 satellites. That's like 3 times as many pieces of tracked hardware as already in space right now. But Starlink aren't the only option. Indeed, OneWeb beat them to the punch, launching 6 satellites earlier this year on a Soyuz rocket out of Kourou in South America. Now, they were actually going to launch 10, but they decided instead to keep 4 on the ground and send up 4 mass simulators. Ultimately, their network is supposed to use 648 satellites in 1,200 kilometers orbit. Their spacecraft are slightly lighter than SpaceX's. They're about 150 kilograms per spacecraft. They have partners like Virgin Galactic and Qualcomm. It's also interesting to point out that they launched on board a Soyuz, which is a Russian-built rocket, and Russia has actually said to OneWeb, sorry, you're not going to be able to sell your antenna here. Russia likes to control its internet, and it doesn't want any outside companies providing direct access to the middle of the country. And this is going to be a problem around the world, I imagine, for all these operators. They're going to have to deal with local internet content rules and censorship and everything. And of course, there's many countries that are, very religiously conservative that ban things like satellite dishes for many people, or they require a lot of paperwork to make sure you aren't watching the wrong kind of programming. So, this isn't necessarily going to provide instant internet for everyone. It's going to provide accessible internet to people where the countries let them do it, I imagine. But anyway, yeah, they're also talking about flying the spacecraft on board Virgin Orbit's launch vehicle and on New Glenn, which again is interesting because Amazon have also proposed a network called Kuiper, which is going to use 3,236 satellites in low Earth orbit. And yeah, they're going to provide the same service as these other options. They haven't launched anything yet, but obviously there's likely to be some collaboration between Blue Origin and Amazon on this front. Elsewhere, both Samsung and Boeing have also talked about satellite networks, but at this time I don't really have any great details on this. So with all these proposed satellites and the first 60 Starlink satellites going up, there's now a lot of concern from astronomers. Both amateurs and professionals around the world are going to have to deal with this increase in satellite traffic. The early passes over Europe have been, frankly, spectacular. They've even been bright enough in some case to show up on cell phone video, which is a bit of a problem because Elon Musk specifically said, don't worry, they're satellites. They will only be visible just after dark. They won't be that bright. And this is not looking like the case. The satellites are still in the commissioning phase. They're still trying to spread them out, setting up the spacecraft, getting the solar panels tracking the sun. So this visibility is not necessarily indicative of their ultimate visibility. That being said, we're still talking thousands of satellites, and that is making a lot of people worried. Despite there being a few high-profile space telescopes, the vast majority of astronomy research is still performed using ground-based telescopes. You can set up a small telescope a lot more cheaply than you can launch a spacecraft. The large telescopes are way larger than anything in space, and the instrument that you put on the backplane, those can be swapped out a whole lot easier because you don't have to send up an entire space shuttle and maintenance crew. And that means the instruments are much more high-tech. The big telescopes have, of course, all moved far away from civilization now, to sites that don't get polluted by city lights. Aircraft have to be routed around them to make sure they don't conflict with the field of view, but satellites can't change course and they go everywhere. Yes, there are thousands of satellites already, but in the long term, this is going to be way, way more. I mean, at least telescopes at the South Pole, for example, they're not going to deal with any of these satellites because they are all lower inclination than that. The Large Synoptic Survey Telescope is probably the premier example of a flagship instrument that will have to deal with this on every single picture. Its field of view is very wide because it's supposed to survey the entire sky every few days and collect information on sources that are changing brightness, stars that are flaring, near-Earth asteroids, things like that. And based on the field size and the 15-second exposure rate, the estimate is there will be at least one satellite in every single frame. Now, they do take 2 frames one after the other so that they can subtract out cosmic rays, and they will probably be able to subtract out satellites. But if you figure out a satellite track passing across its 30 gigapixel sensor, you're still going to be losing 3 to 5 million pixels due to these satellite passes. And that will mean that you're either missing data or possibly generating false alarms. Currently, I can't think of any instrument which will be rendered totally useless by this, but it will mean a lot more work on the astronomers' part. They'll not only have to spend more time processing the data, but they will also have to take more flat fields and more images so that they have the data on the back end to subtract out these defects in the ultimate frame. I mean, it's a good thing that astronomy has gone digital, because back when I was doing astronomy degrees, they were still teaching me about photographic plates and how to develop them. Also, you got to consider that telescopes aren't just working in the optical range. This will affect all frequency ranges and right out into the radio, because of course these things are talking to the ground using various radio signals. But anyway, as I said, the satellites are still getting commissioned and we don't know what they will look like in their final configuration. The only thing we know is that there will be a heck of a lot more of them once the network starts really getting built out. People have been taking pictures of them with various effects. I went out looking for them last night on a predicted pass, and there was, fairly large gaps in the cloud. I could not see any of them. So either they were too faint, or the prediction were wrong, or the clouds were in exactly the wrong place to hide 60 spacecraft. But this is becoming quite a contentious issue on Twitter, and I wish people would be a little more civil. I've seen people having to make their accounts private because of, hate mail, let's say. I've seen the ridiculous argument that astronomers should be grateful for this because it will finance SpaceX to develop cheaper launch vehicles that can launch bigger space telescopes, and everyone will ultimately be happy. But that's like telling a town that has had their local swimming hole polluted by an oil refinery that they should be grateful because it means that the gas will now be cheaper and they can drive to the nearby water park, which coincidentally is operated by the same people that run the oil refinery. And on the other hand, I've seen people saying that all those satellites in the sky will ruin the night sky for the general public forever. And I'm sorry, but I think this is ridiculous because every time I've been out at community events and pointed out satellites, it's made people much more excited about the night sky in general. But the night sky is a shared resource and it shouldn't be polluted with impunity. And that's why things like advertising satellites are absolutely prohibited by the FCC and most other agencies that control launches. I don't think SpaceX, OneWeb, or Amazon are setting out to be villains, and I do think the concerns of astronomers do need to be addressed and accounted for as much as possible. And at the very least, we do see Elon Musk talking about this already, and the truth is, there's only so much that will be possible in albedo reduction. And these satellite constellations are only going to go away if there is a financial failure. I don't have an easy solution. Maybe one idea is to compute a science loss from each new satellite, figure out how likely it is to pass through a telescope and how many pixels will be ruined, and then figure out the cost of the telescope. So yeah, LSST losing 3 megapixels per frame, that's 0.1% of its value. Have that get paid off into a fund for launching new space telescopes. It's not the best solution, but it's one idea. Ultimately, the sci-fi future that I want to live in, the one that I dream of, is going to have even more stuff in space, even larger things in space. And hopefully some of those will be really spectacular space telescopes that absolutely dwarf our imaginations today. I'm Scott Manley. Fly safe.